Good day. Welcome back to our basic calculus class on our chapter 1, limits and continuity. This time we're going to talk about continuity at a point. This is our lesson number 6. Our objectives are to illustrate continuity of a function at a number, determine whether a function is continuous at a number or not, and determine the two types of discontinuity. In this section, we will study the notion of continuity. This concept is so essential to calculus that without it, the whole subject, the whole subject of calculus will not have been developed as we know it today. It is arguably one of the most important concepts, not only in this discipline, but also in other branches of mathematics. So it is very important to study the notion of continuity. So observe from these four figures, figure 1.6.1, figure 1.6.2, figure 1.6.3, and figure 1.6.4. We say that a function is continuous at a point. So makaingon ta nga ang usa ka function is continuous at a point if we can trace the graph of the function and pass through the point. Moagi ka sa point nga dili nimo alsahon ang pen or without lifting our pen. So pag inana gani ang mahitabo sa graph nga pwede ka maka trace sa line without lifting our pen, kahit ko-cross ka pass through that given point, then that is continuous at a point, right? So here, in the four figures, from figure 1.6.1, figure 1.6.2, figure 1.6.3, and figure 1.6.4, it's only figure 1.6.4 makita nato kung ato i-trace ang pen, we can trace it without lifting our pen. Even mo agi siya ani nga point. Compared to figure 1.6.1, igabot nimo diha since this is open, so imo i-left imong pen, then continue na pagka. So that is not continuous. That is the same also with 1.6.3. Okay? And here, mas lalo na si 1.6.2. So, pag-ana, darayang padayon diri sa ubos. So, therefore, out of the four figures, it's only figure 1.6.4 ang matawag nato na continuous at a point. Kay matrace nato siya without lifting our pen, bisan pa mo agitaan nga point. Now, in figure 1.6.1, the function is not defined at A. So as you observe here, it's open, right? While in figure 1.6.2, the limit as x approaches A does not exist, right? So here, kung imo matan-aw, dili sila kapareha og limits. Sa tos ibaba, sa pod na diri sa ubos. In 1.6.3, both the value of the function at A, right, and the limit as x approaches A exist but are not equal. So this gives us an idea about the condition for a function to be continuous at A. And with that, we have the following definition. Take note. Definition 1.6.1. A function f is continuous at a point siya if and only if limit of f of x as x approaches A is equal to f of A. Meaning, ang limit ni f of x as x approaches a, kapareha pod siya sa dihang ang f of a nato the same sila og numbers or result. So, we have these three conditions. Take note, ito ning timan-an. Number 1, three condition must be satisfied for a function f to be continuous at a. So, manintulo ka buok nga atong timan-an para makita nato nga continuous siya at a. Number 1, if ang f of a nag-exist na a. Ikaduha, if limit of f of x as x approaches a exist, meaning na ay limit. And ikatulo, pinaka-importante, dapat ang limit ni f of x as x approaches a kapareha sa result sa f of a. So, manay ilhanan nga continuous at a. So, take note, kaning tulo ka condition, dapat ma-check ni siya, ma-satisfied, para matawag na to nga continuous siya at a. On the other hand, if f is not able to satisfy at least one lang sa tulo, so ani wala nag-exist, automatic, it's what we call discontinuity at a. Or f is discontinuous at a. So, at least one lang ani wala, automatic siya nga discontinuity or discontinuous siya at a. I hope that is clear. And we have types of discontinuity. Actually, we have two. We have type 1 and type 2. So, take note sa tulo ka condition. First condition, may data value sa f of a. Diba? And number 2, natay limit nga nag-exist. Number 3, ang limit nga nag-exist o ang f of a, the same. So here, type 1, if f is discontinuous at a and condition number 2 is not satisfied, meaning there is no limit, automatic, that is discontinuity. And that is called essential. So natay duha ka types of discontinuity. The first one is essential. If condition number 2 hindi siya na-satisfied, meaning yung condition number 2 yung nag-fail, that is what we call essential. Ang type 2 naman, if f satisfy condition 2, meaning there is a limit existed, but fails, pero yung condition 1 or condition 3 wala, meaning yung f of a, tapos yung number 3 nga condition wala, hindi nag-satisfy, that is discontinuity, and that is called removable. Okay? Pag si condition 2 yung not satisfied, essential siya. Either say condition 1 or 3 yung not satisfied, that is removable. And take note, a function that has a removable discontinuity at the point can be redefined or manipulated straightforwardly so that it will no longer be discontinuous at that point. So, pwede nimo usbon ang sa removable para mahimong continuous. But for essential, you cannot. Okay? So, that is the difference between essential and removable. So, here, refers to the given graphs or figures kaginina. So, the function whose graph is given in 1.6.2 here, this is an example of essential discontinuity at a. That is because the limit of the function as x approaches a does not exist. Diba? Hindi yan na-satisfy yung condition number 2. That's why this is essential discontinuity at a. Tapos yung figure 1.6.1 at figure 1.6.3, they belong to removable discontinuities at a. Because they satisfy condition 2, there's a limit, pero they are discontinuous since they fail to satisfy condition 1 and condition 3. Ito yung itsura ng tinatawag nating discontinuity or removable discontinuity at A. So magkaiba. So mani ang porma sa essential and mani porma sa removable, ba? Maklaro dayon nato unsay kalahian sa duha. So we have some examples. Consider the function f whose graph is shown below. Ito. Determine whether f is continuous at its given number. If f is discontinuous at the number, determine the type of discontinuity. We have only two types of discontinuity, the essential and removable. So we have 5 examples. A sub 1 equals negative 2.5. B, A sub 2 equals negative 1. C, A sub 3 equals 0. D, A sub 4 equals 0.75. And the last one is A sub 5 equals 2. Tato siyang tagsa-tagsaon. And we need to determine if this is continuous or discontinuity. First, we have A sub 1 equals negative 2.5. So from the graph alone, here, this is the portion of A sub 1 equals negative 2.5. So tanawon pa lang nimo ang graph, this is discontinuous at A, diba? And since this is discontinuous, we have two types, the essential and removable. So from the graph alone, this is the same with 1.6.2. So this is essential discontinuity at A sub 1 equals 2.5. So from the graph alone, makiilhan na nimo daan na this is discontinuous. Then, ang pagkaiba ni removable at essential, makikita mo na rin agad. Next, letter B, A sub 2 equals negative 1 here. Diba? Open siya. So, this is discontinuous again. So, ang pagkaiba kang negative 2.5, this is essential. This one is what we call removable. So, this is the same with case of graph 1.6.1 at 1.6.3. This is removable discontinuity at A sub 2 equals negative 1. Letter C. A sub 3 equals 0. So, here. So, as you observe, na pag i-trace nimo ang graph through 0 without lifting your pen, kaya. So, meaning, this is continuous. So, this is continuous at A sub 3 equals 0. So, notice yung pagkakaiba. Yung negative 2.5, this is essential discontinuity at A sub 1 equals negative 2.5. Ito naman, this is removable discontinuity at A sub 2 equals negative 1. And here, we have continuous at A sub 3 equals 0. How about letter D? A sub 4 equals 0.75 here. So we have the asymptote. This is what we call the asymptotic to the line of x equals 0.75. So meaning that f has an infinite limit as x approaches 0.75. Therefore, yung second condition, hindi natin na-meet, automatic. This is essential discontinuity. Right? Diba? At A sub 4 equals 0.75. So, we know sa definition, pag hindi na-satisfy yung number 2, that is essential discontinuity. Pero pag number 1 naman at number 3, that is removable. Next, A sub 5 equals 2 here. See? So, pag ititrace mo using pen from here, padong diha or padong ubos padong ibabaw, pwede nimo matrace without lifting your pen. Automatic, this is what we call continuous at A sub 5 equals 2. So, klaro ang kalahian sa discontinuity o continuous. Pag discontinue naman siya, discontinuous, klaro ang pagkakaiba ng essential at removable. Right? So, this is essential. So, using graph, mas madali nating ma-determine. Now, let's have this one. Using definition 1.6.1, determine whether each of the functions given below is continuous at the given value of a. If the function is discontinuous at a, determine the type of discontinuity involved. So we have three examples ato siyang tagsa-tagsaon so that we can clearly determine if this is continuous or not and what type of discontinuity if that is not a continuous. Okay? So let's start with letter A. G of x equals 4 minus 3x over x squared minus 1. And RA is equal to 2. So take note, we need to satisfy three conditions. Number 1 is find the f of a. So here we have g of x equals 4 minus 3x over x squared minus 1. Now our a is 2. So g of 2 equals 4 minus 3 times 2 over 2 squared minus 1 equals 4 minus 6 over 4 minus 1. So this is negative 2 over 3 or negative 2/3. That is our g of 2. So we have existing for our first condition, our f of a. Now for second condition, we need to find the limit. The limit of g of x as x approaches 2. So equals limit of 4 minus 3x over x squared minus 1 as x approaches 2. So applying the laws of the theorem of limits, so we get what? 4, limit of 4 is 4, right? Minus 3 times the limit of x, which is 2, over the square of 2 minus 1. In-apply na natin na yung different theorems. So 4 minus 6, this is 4 minus 1. So we get negative 2 over 3 or negative 2/3. That is our limit. Okay. So the third condition is, ano yun? Yung limit of g of x must equal to its g of a. So is it? So we get limit of g of x as x approaches to is equal to our g of a. Right? So as we observe, is it equal? Yes, because our limit of g of x as x approaches to 2 is negative 2/3 and our g of a is negative 2/3. Meaning, this one is continuous at a equals 2. So again, our g is continuous at a equals 2. Now let's have the second example. H of x equals 4x squared plus 1 if our x is not equal to 0. And then h of x equals negative 1 if our x equals 0. And our a equals 0. So first, we need to find our first condition. If there is a existing result for our h of a, So take note our a is 0. So our a is equal to 0. So here we have x equals 0. So therefore our h of 0 is equal to negative 1. For second, we need to find the limit. The limit of h of x as x approaches 0. So meaning, our h of x is not equal to 0 kundi approaches lang. So that is not equal to 0. So we need to use limit of ito. 4x squared plus 1 as x approaches 0. So we have 4 times 0 squared plus 1. The answer is 1. Now the third condition. So our second, there is a limit. Our first, we have the value of h of a. But the problem here, we have negative 1, and here we have 1. Meaning, our limit of h of x as x approaches 0 is not equal to our h of a. Therefore, this is a discontinuity. And what type of discontinuity? Since ang hindi satisfy nito is yung third condition, therefore this is removable. So our h has a removable discontinuity at a equals 0. And take note, pag removable discontinuity, meron tayong babaguhin para maging continuous. So, balikan na to ang given. Take note, ang result is negative 1 at 1. So, unsa may usbo na to dire para magkapareha sila. So, instead of negative 1, pwede nga atong h of x. So, here, h of x equals 4x squared plus 1 if x is not equal to 0. Tapos, instead of negative 1, we have 1 if x equals 0. As a equals 0. So, with that, so we have here 1 and we have 1 na. So, we can have continuous value of h at a equals 0. So, that is removable discontinuity. Next, we have the last example. T of x is equal to square root of x minus 2 if our x is greater than or equal to 2. And then x cubed minus 1 if our x is less than 2, where our a is equal to 2. So first is we need to have our t of a, so which is 2, our a. So asa man dire. So here we are going to use this one. X is greater than or equal to 2, right? So our t of 2 is equal to square root of x minus 2 equals 2 minus 2. So the answer now is 0. So that is our t of 2. Next is the second one, the limit of our t of x as x approaches 2. So take note, we have x is greater than 2 and x is less than 2. So we need to find what? We need to find our limit of t of x as x approaches 2 from the left, and the other one is limit of t of x as x approaches 2 from the right. So from the left, meaning less than, so we need to use x cubed minus 1. So that is 2 cubed minus 1. So what is 2 cubed? That is 8 minus 1 equals 7. And then here, for limit of t of x as x approaches 2 from the right or greater than, So we got square root of x minus 2. So we got square root of 2 minus 2. So the answer is 0. Take note, our generalization, dapat ang limits sa right ug left magkapareha sila. Pero here, they're not. Diba? So limit of t of x as x approaches 2 from the left is not equal to limit of t of x as x approaches 2 from the right. Therefore, limit does not exist. Okay? So what is our third condition? Limit of t of x is not equal to our t of a. Diba? So therefore, this is a discontinuous. Now, what type of discontinuity? Since ang nag-failed is ito, the second one, so this is what we call T as an essential discontinuity at 2. Okay? So always remember the three conditions to determine if there is continuity or wala. So dapat ma-satisfy ang first are finding the f of a, then the limit, and then dapat mag-equals yung volume ni f of a tapos the limit of f of x. And then pag discontinuous, we have two types. The essential discontinuity if nag-failed yung second condition. And then the next one is what we call the removable discontinuity if nag-failed naman yung 1 or ang third condition. So that's it for our lesson about continuity at a point.